Okay, hello guys, welcome to my Cycle 7 presentation. Today I'm going to cover 4 different chapters which is all about wireless LANs. So I'm going to be covering chapter 26, 27, 28, 29. Okay, let's start with chapter 26. So, the first chapter, chapter 26, Fundamentals of Wireless Network. So first, we will talk about wired and wireless networks. So, wired and wireless networks, what's the difference? There's no big differences between them. Before we were using our devices with wire connection type, the wire itself, it can contain strands of metal or fiber optic material which can run between two devices like RJ45. Well, I can say it's kind of the path of data transmission. And wireless networks, well, we have Wi-Fi, yes, the easiest one, that can explain everything. We can access our network resources from any location within our location or network's coverage area or from any Wi-Fi hotspot. So personally, I love wireless networks because sometimes when I am outside and when I have to use my laptop with network, I can just open my hotspot with my phone and connect it to use. I don't need to find a cable, like Ethernet cable and socket to connect with it. I do love wireless network. It has mobility and easy setup too. Okay, so wireless LAN topologies. So, wireless communication, it does not require any space. It is working as RF signals, which is radio frequency. So left for picture, we can see that unidirectional communication. So let's think the transmitter want to communicate with receiver. So it should show the same frequency and using the same channel to send the data. However, on the right picture in here, it looks a little bit more complicated with signal because this is bidirectional communication. In this picture, we can see that the signal is not coming from only one side, like left, transmitter to receiver, but it's sending and sending back together right, like this. So this is actually coming from the both directions. So devices can send data to A and B, and it is also sending to B to A the data. Next, BSS, Basic Service Set. The concept of BSS is very simple. All stations must hear each other. The associations are dynamic and managed by the use of distribution system service. Inside BSS, we can find AP and SSID and BSSID. Excuse me. AP serves as a single point of contact for every device using BSS. Also, AP also established its BSS over a single wireless channel, and for sure, they are using the same channel to communicate. And BSSID. This one is BSS identifies and it recognizes the access point or router because it uses a unique address which create the wireless network. Oh, and in addition, malware uses Wi-Fi BSSID for victim identification. It recognizes the access point or router. The basic service set identifier, BSSID, is the MAC physical address of the wireless router, or access point that the user uses to connect over Wi-Fi. You can verify the BSSID on the Windows system by running the command below. This is really interesting. So, distribution system supporting BSS. Okay, so AP must be connected to the switch by a trunk link that carries the VLANs so that it can be extended to mapping multiple VLANs and SSIDs. Also, I didn't know that, but when AP uses multiple SSIDs, it is trunking VLAN over the channel. And the conditions is that the clients must use the appropriate SSID that has been mapped to the respective VLAN. I took some time to understand, but this is a very interesting point. So let's learn other wireless topologies. Repeater. I knew that repeater is regenerating the signal, which is blurring, and it increases the power of the signal, like we call it rebounding, yes? And in this chapter, the concept of repeater is the same, extending wireless coverage beyond the normal AP footprint with a repeater. It can retransmit to the new area around the repeater. Workup bridge. So this one allows you to extend the accessibility of the remote network, so wireless connection is more practical in this case. WGB Workup bridge is working as an external wireless network adapter for a device that has none, as this picture. Client A here is just a client in wireless, and B is associated with WGB in the middle. Okay, so chapter 27, analyzing Cisco wireless architectures. Okay, so autonomous APs offer one or more fully functional. It is just an extended switch network. Why? Well, look at the picture. We have core layer and 3 more layers, and most of them are switch device, and we have APs down below. This feature explains that the SSID is connecting to VLANs at the access layer too. Also, autonomous AP, it offers a short, simple way for data to travel between the wireless and wired networks. So, the data will travel only through the AP to the network on the other side. Very familiar feature. Cloud-based AP architecture. Well, cloud never leaves us alone like this. It always goes together. So we can upgrade and configure changes to APs in the enterprise from the cloud. And in this picture, they consist of 2 distinct paths. First, a control plane panel, traffic used to control, configure, and manage the AP itself. And data plane, this is end user traffic passing through the AP. Okay, let's learn about WLC. It is wireless LAN controller, and when we locate the WLC in the middle, central location, we can maximize the number of APs joined to it. We call that centralized WLC deployment. So in this picture, we have human below in lightweight APs and unified WLC on top. So we have single WLC here, and obviously the network might have more APs. Like picture or more, because we don't know how many will be accessed and who will be connected too. So these single human can be duplicated like so many, but we don't know how many it's gonna be. So typical unified WLC can support a maximum of 6,000 APS. However, when we need more APS, we should add more WLC because it has limitation too. Now we have cloud-based WLC. So what is the differences? Well, we have cloud WLC. That's it. So WLC exists as VM, not as physical device. So Controller can support up to 3000 APS. And if network scales beyond that, additional WLC can be added in VM, which is very interesting. Okay, chapter 28, securing wireless networks. My favorite part, securing networks. As we know, there are vulnerabilities of networks in wired networks, also in wireless networks. Okay, so let's start. Secure connection. I love this picture. So, okay, let's look at the picture. So, client, let's call this man as user. This man opened the session with remote access and shares password. Why? Because their two bad guys are also located in client signal, and he doesn't know who is there, but he's just exposed. I mean, they're in the same range. They can just capture frames by this man, I mean, the user. So, which is on the left of the channel, so it should not be happen, of course. That's why 800.11 standard offers a wireless security, such as trust, privacy, and integrity to secure the network. So, yes, look, whatever the client or user or this man put on the server, like another man can listen to it, which is really bad. Next one, authentication. Okay, authentication means that recognizing the user's identity, such as asking who you are and are you the one? Wireless authentication can make many features. It can be text string, which is stored in the client device and presented directly to AP. Also, using wireless network without doubting is very serious problem. The fake AP can send beacons or associate clients just like real AP. So let's imagine you just get into the fake AP. We're just feeding the attacker in our information. They can intercept all communication. Moreover, it can also send spoofed message to frames. Okay, next one. I will talk about something very familiar, man-in-the-middle attack. So, how to prevent this one? The client should authenticate the AP for sure before the client itself is authenticated. So, every frames by client should be authenticated too, as this picture. Encrypting wireless data. Okay, same situation, but those two men, they have no idea what is the password. AP also maintains a group key, and the group key uses when it needs to send encrypted data to all over in its cell. At one time, so each of them uses the same group key to decrypt. Okay, so this is how it looks. Message integrity. MIC message integrity check is one of security tool which can protect our data from data tampering. Once the recipient decrypts the frame, it can change to the secret stamp. And if two stamps are identical, the recipient is safe. Like this picture. Wireless privacy. Okay, TKIP, Temporal Key Integrity Protocol. It adds several security features. MIC adds a hash value to each frame as integrity check to prevent tampering. Timestamp. A timestamp is MIC to prevent replay attacks. Key mixing algorithm. Well, this feature provides a record of frames sent by unique MAC address, and there are some more, but I will just skip it. Okay, chapter 21, building a wireless LAN. Connecting a Cisco AP. Okay, so in this picture we can see two differences. Okay, our right one we added CAP, WAP with WLC. Left, autonomous AP support browser-based management sessions via HTTP and HTTPS. And lightweight APs we can manage from a browser session to WLC. So we need a web browser to connect. And this can be done with only after WLC has initial config and management IP address. We can also connect to WLC with SSH session. So for this one, I watched a video which is connecting a Cisco WLC because it is more easy to understand for me. Yes, and it was easier than I concerned. It has several different types of connections as usual. Just needed to be careful with ports and interface. Alright, so speaking of ports, let's talk about it. We have 4 different ports in controller. Service port is used for out-of-band management, system recovery, and initial boot functions. Distribution system port for all normal AP and management traffic. Console port, also for out-of-band management and system recovery, but as synchronous connection to a terminal emulator and redundancy port used to connect to a peer controller for high availability. WLC interfaces. Each interface is assigned to physical port and VLAN ID, and Cisco controllers support 5 different interfaces. So management interface for management traffic, it is also used to terminate CAP web tunnels between the controller and its APS. By the way, CAP web is control and provisioning of wireless access points. It enables a central wireless LAN access controller to manage a collection of WTP. Redundancy management, the management IP address of redundant WLC, is part of controllers, and WLC uses the management interface address. Virtual interface, IP address facing wireless clients because it is virtual, performing client web authentication and supporting client mobility. Service port interface, it bounds to the service port and is used for out-of-band management. Dynamic interface, it is just used to connect VLAN to WLAN, wireless LAN. So the thing is, other contents in chapter 29 was very readable stuff. I mean, we just need to read and watch some additional video to get used to it and get some more information. So I will close my PPT right now. So hope you guys enjoyed it, and I will see you guys in the next cycle. Thanks so much.